Today we're going to be talking about density curves and normal distributions. A density curve describes the overall pattern of a set of data. It is a mathematical model for the distribution, meaning it's an idealized description ignoring minor irregularities as well as any outliers. To be considered a density curve, a curve must fulfill two requirements. It must be on or above the horizontal axis, and it must have an area of exactly 1 underneath it. When talking about density curves, we deal mostly with mean, median, and standard deviation. The median of the density curve is the point that divides the area under the curve in half. We think of the median as a point which the curve would balance if the curve were made of a solid material. On a normal curve, these two will be the same place, the exact center of the curve, while on a skewed curve, the mean will be pulled away from the median towards the direction of the tail. For example, this curve is skewed right, and as you can see, the mean and median are pulled right. When dealing with density curves, normal distributions are particularly important. A normal curve is symmetrical, single-peaked, and bell-shaped. The normal curve describes the normal distributions, which all have a mean of mu and a standard deviation of sigma. The mean and median are always the same on a normal distribution. The standard deviation of a distribution controls the spread. The larger the standard deviation, the more spread the distribution. The most important property of a normal curve is the 68-95-99.7 rule, also known as the empirical rule. This rule states that on a normal curve with a mean of mu and a standard deviation of sigma, 68% of the observations fall within 1 standard deviation of the mean, 95% fall within 2 standard deviations of the mean, and 99.7% fall within 3. When dealing with normal distributions, we use a shortened notation to discuss the meaning and standard deviation, which is n mu, comma, sigma. We also use percentiles to discuss the different points on a curve. An observation's percentile is a percent of data to the left of the observation. The median would be the 50th percentile because 50% of the data lies to the left. The first quartile is the 25th percentile, and the third quartile is the 75th percentile. Thank you for watching our informative video. Oh boy.
Ta-da!